Alright, so now let's solve a very tricky and high frequency data engineering interview problem called median search frequency. And apparently this problem has also been asked in the Google interviews. So now here's why this problem is dangerous. If you try to solve it the obvious way, it will fail at scale, right? So here we are given a table called searches, where searches is the number of Google searches, right? And num users is how many users made those many number of searches, right? So instead of raw data like 1, 1, 2, 3, 3, 3, we get a compressed version saying 2 users made 1 search, 1 user made 2 searches, and then 3 users made 3 searches. Now the question is, find the median number of searches across all users. So let's quickly understand what median means, right? So first of all, we sort all the values and we pick the middle. And if the number of values is even, we take the average of the two middle values, right? So if you see this example, if we expand this data, we will get 1, 1, then we will get 2 one time, that is 2, and then we will get 3 3 times. So it will become 1, 1, 2, 3, 3, 3. So the total elements are 6 and the middle values are 2 and 3, right? So the median will be an average of these two middle values, which will be 2 plus 3 divided by 2, that is 2.5. But here's the real challenge. In real world systems, you cannot expand this data, right? It could be billions of rows. So the real question becomes, how do we find the median without expanding the data set? And the trick we will use is track the positions using cumulative frequencies instead of the actual rows, right? So let's try to understand this solution step by step. First of all, what we will do is we will compute the total number of users, right? So we simply sum the num users and it comes out to be 6. That is 2 plus 1 plus 3, which is 6, right? Now we don't care about the individual rows. We only care about the position of the elements, right? Now we find the positions of the median elements. So the total users is 6, which is even. So the lower median index would be 6 divided by 2, that is 3. And the upper median index would be 3 plus 1, that is 4, the next index, right? So we need to find the third element and the fourth element. And then we can take the average of those two. So median is not about the values, it is about the positions in a sorted data set, right? So now comes the most important trick in this problem, finding the cumulative frequency. So now instead of expanding this data, we simulate the positions using counts. So let's compute the running totals. So for searches equal to 1, we have 2 users, right? So the total is 2. Now for searches equal to 2, we have 1 user, right? So total till this point becomes 3 now, right? 2 from the earlier row and 1 from this row. Then for searches equal to 3, we have 3 more users. So total till this particular row till searches equal to 3 becomes 6, right? So this is how the cumulative users column looks like, 2, 3 and 6. So now what cumulative frequency tells us? It tells us how many elements we have seen so far, right? Till this point. So this effectively gives us positions without expansion, right? Now we convert cumulative values into ranges. So we compute the previous total. That is nothing but the total till the previous row, right? So for searches equal to 1, we have the range from 0 to 2 because that is the first row. For searches equal to 2, we have the range starting from 2, which is the total from the last row till the total of this row, that is 3, right? Then for searches equal to 3, in a similar fashion, we have a range from 3 to 6, right? So now each row represents a range of positions, right? And remember, for calculating the median, we only need positions, right? Now what we need to do is, we need to understand that each value occupies a range of indexes in the sorted array, right? So search value equal to 3 occupies the positions 4, 5 and 6, which means if at all we had expanded this data, right, the way we were talking about expanding it earlier, then search value 3 would have occupied positions 4, positions 5 and position 6, right? We can figure it out now using these ranges, right? Without actually expanding the data. So now we simply check where do positions 3 and 4 fall, right? So we check ranges. Position 3 lies in the range 2, 3, which has a search value of 2, right? And position 4 lies in the range of 3, 6, which has a search value of 3, right? So instead of finding the median directly, we find the bucket that contains the median positions. Now we take the average, right? So we take the average of 2, right, and 3, and that gives us 2.5. So for even count, median again will be the average of the values at the 2 positions. And if the count had been odd, then there would have been just one median value and that would have been the result, right? So now having understood the solution, let's try to translate this into SQL, right? So first of all, we start with the first CTE called indexes. And what we do inside of this is we simply compute the median positions. So we calculate the first median index and the second median index, right? And we handle both odd and even cases over here using the case statement, if you can see, right? Now we compute the cumulative frequency. So this gives us the running totals, right? And then also gives us the position tracking without actual expansion, right? And this is actually a core transformation step, if you see, for this particular problem. Now we compute the previous total using lag. And why do we do this? Because we need ranges, right? Which will be total from the previous row and the total from the current row, right? And without this, we cannot identify the correct bucket where our median indexes lie, right? Now we simply cross join the indexes to bring the median positions into each row. So this will allow us basically to compare the bucket ranges with the median indexes that we have calculated. Now this is the heart of the solution. We filter the rows where index is greater than the total from the previous row and is less than or equal to the current row total, right? And this will mean this row contains the median position that we are looking for, right? And we simply apply it for both the first median and second median to filter out both the rows corresponding to these two median positions, right? So for even number of values, we will have two different rows for first median position and second median position. But for odd number of values, I mean the examples where we have odd number of users, in those cases, first median position and second median position both will be same. So we will get only one row filtered out, right? So this is the exact trick the interviewers are actually looking for. Now finally, we take the average of searches, right? And why average? Because for odd, again, we have one row. So average will be the value itself. And for even number of rows, we will have two rows and the average will be the median, right? So again, just to summarize, instead of expanding millions of rows, we converted the problem into position tracking using cumulative frequency. And this is exactly how data warehouses, distributed systems, big tech pipelines, all of them compute median at scale, right? So now if you understood this approach, you just learned one of the most important patterns in advanced SQL interviews. So that's it for this particular problem. I hope you understood this very well. And now I will see you in the next one. Happy coding.